This is the James Webb Space Telescope, the largest space telescope to exist so far. Launched on 25th December 2021, this marvel was expected to show us regions of space which we had never seen before in detail, and it did. The James Webb Space Telescope discovered something in the early universe that has surprised everyone. And this discovery is even compelling some to think that the Big Bang is over and maybe our science isn't complete enough to trace the origins of the universe. Therefore, we may need to reconsider the notion of the universe originating from an explosion. You're watching Into the Unknown, and in today's video, I'll be showing you what has the James Webb Space Telescope discovered at the edge of the universe, that is, to a great extent, disproving our understanding of the universe. But before we continue, take a moment to subscribe to Into the Unknown and click the bell icon. In September 1989, plans for a high-tech telescope, then named the Next Generation Space Telescope, came into existence. Ever since then, decades had passed, and work was underway to build this marvelous space telescope. After 30 years of consistent efforts and with over $10 billion spent, the James Webb Space Telescope was finally completed in 2019. Following which, it was launched into space in December 2021 and started orbiting the Sun at the L2 Lagrange point at a distance of 1.5 million kilometers from the Earth. The James Webb Space Telescope is the largest space observatory which specializes in infrared. The Webb Telescope's structure is simple. The primary mirror is composed of 18 hexagonal segments. This primary mirror intercepts infrared light that is then reflected onto the secondary mirror. The secondary mirror directs the light into the scientific instruments where it is recorded. The sun shield is what controls the telescope's temperature and allows it to cool down. It does this by radiating the telescope's heat into space, and thus ensuring the right temperature for the telescope to operate. Next, there is the spacecraft bus, which is extremely important for the telescope as it provides the Webb with electrical power and controls, such as thermal control, altitude control, command and data handling, along with communication and propulsion. Then there is the star tracker. Data of the star tracker controls and aligns the telescope in a way so that the telescope's target appears in the field of view. Although the Hubble Space Telescope was no less than a wonder for astronomers in terms of exploring space, but it did have limitations, which prevented astronomers from gathering more detailed data. However, the best thing about the James Webb Space Telescope is that it's extremely powerful and can collect more detailed data than Hubble. The Webb Telescope is roughly 100 times more powerful than Hubble, and its infrared system and its ability to see the distant past simply outperforms Hubble. With such amazing capabilities, the goals of the James Webb Space Telescope are to detect light from over 13.5 billion years back in time to see the formation of the first stars and galaxies forming in the early universe. Detect the faintest and earliest galaxies of the universe and compare them to today's galaxies and understand their evolution and how galaxies assemble over billions of years. See through the thick clouds of dust into the regions where stars and planetary systems are born. Study and explore the atmospheres of exoplanets and hunt for possibilities of life on planets in the universe. However, there is no wonder that our universe is filled with stuff we don't know about. And with something as powerful as the Webb Telescope in space, we are bound to uncover some puzzling realities, and that's exactly what the James Webb Space Telescope has recently done, while exploring the early universe of the Dark Age period, when, according to our models, the universe was empty space. The Webb Telescope found things that should not exist. But before we dive into this topic, it's important to understand how our current models explain the origin of the universe. According to how our current models explain the origin of the universe itself began from a very strong explosion, called the Big Bang. Following the explosion, the universe experienced inflation, which is a burst of expansion during which it expanded faster than the speed of light. Following the inflation, the universe continued to expand, but at a slower rate, and then the universe was filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. This all happened in the first few seconds. And then, in the first 3 minutes, the light elements of the universe were born during a process called nucleosynthesis. According to scientists, the universe, for the first 380,000 years, was too hot for light to shine, and hence light remained as fog. Following this, the Dark Age began. This was the period of the early universe where our universe was mostly empty space. No planets, stars, or galaxies. Nothing existed other than particles and atoms. The Dark Age began around 400,000 years after the Big Bang and lasted for several hundreds of millions of years. After 400 million years after the Big Bang, the universe began emerging from the Dark Age, and matter started collapsing enough to form the first stars and galaxies. Following this, the universe continued expanding, and celestial bodies kept on forming. However, around 5 or 6 billion years after the Big Bang, a mysterious force, which we know today as dark energy, started accelerating the expansion of the universe. And roughly 9 billion years after the beginning, our solar system and the planets formed. This is how our scientific data, study, and models explain the universe's beginning and evolution. However, given the Webb telescope can look far back in time, it explored the early universe and discovered something shocking, which contradicts our models. But before we continue, take a moment to subscribe to Into the Unknown and click the bell icon. While exploring the early universe, the James Webb Space Telescope discovered galaxies forming in the Dark Age. Images from the Webb telescope suggest that these galaxies are much bigger than our Milky Way and convert close to 100% of their gases into stars, which is extremely unlikely and only possible in theory. This directly goes against our models explaining the universe. Because as explained earlier, the Dark Age of the universe was empty, and there were no stars, galaxies, or planets in existence in that period. But the extremely giant structures which appear to be galaxies or star clusters detected by the Webb telescope date back to the Dark Age of the universe. This has puzzled scientists and astronomers alike, because our models and scientific data fail to explain such an anomaly. Some suggest that this questions our theory of the Big Bang and how the universe may have formed, and that the universe didn't form due to the Big Bang, but something else that our science cannot explain yet. Some experts further point at our scientific knowledge being inadequate and not correct. On top of that, the Webb telescope also discovered another galaxy that formed roughly 550 million years after the Big Bang. This discovery again sent shockwaves throughout the scientific community. This galaxy is actually very small, and interestingly is producing stars at a great pace. And being only 16 kiloparsecs wide, this not just makes it the smallest galaxy we have discovered so far, but also quite confusing, because it defies our science considering its size and the amount of stars it produces. These anomalies not only challenge our existing theories and scientific models, which over the years have been really successful in explaining our universe, but strongly hint that our early universe expanded even faster than what we thought, and that there may be other forces and particles that we haven't known anything about yet, which may have been responsible in forming these early galaxies and expanding the universe at a different rate. Experts have tried explaining these anomalies by suggesting theories such as that there may be unknown mechanisms which accelerated star formation in the early universe, resulting in the formation of these galaxies in the early universe. Another possibility suggests that early galaxies may have formed because our universe expanded faster than we had thought. Scientists explain this by suggesting that our universe exists among many others, and when black holes from other universes approach our universe, their gravitational interactions with our universe can alter the rate of expansion of our universe. However, this suggestion that other universes exist strongly hints at the possibility that the cyclic theory may be correct. What is the cyclic theory, you may ask? The cyclic theory is a model of cosmic evolution which suggests that the universe undergoes cycles of expansion and contraction, resulting in the universe starting with a Big Bang and ending in a Big Crunch. And this endless cycle continues, and hence many universes exist. However, the possibility of such a theory being correct is highly debatable, and tracing other universes may not even be possible. And if cyclic theory is really the correct one in explaining the cosmic evolution, our science would require a paradigm shift, and we would need to rewrite textbooks about the universe's beginning. The James Webb Space Telescope surely is a wonder, and its capabilities are simply overwhelming, and this discovery of something we had never seen before hints at how the Webb telescope will unravel more secrets as it operates in the years to come. If you enjoyed this video, give it a thumbs up. Share your thoughts or questions in the comment section below. Don't forget to subscribe to Into the Unknown for more amazing content, and ring the bell icon to stay tuned.